whatever programs you want to start up, accessing whatever malware you want it to access. By automating the environment, you not only speed things up and allow you to analyze malware much faster, you always have the same results. You have a reliable and consistent process which always happens, which helps keep your results consistent. If you want to fool around with SADnets, there's a great open source SADnet out there called Truman. It was written by Joe Stewart of SecureWorks. If you Google Truman, or actually if you look in the notes of my presentation, which will be online at Owasp and at my company site, CoreLogic.com, I have all the links in there. But Truman is a great open source SADnet to get you started. Joe Stewart released it, I think maybe 4 or 5 years ago. He has not updated it since, and he has said that he's not updating it. So it's really great base framework for you to start working on. That's a 3 or 4 minute overview of SADnets. If you go to my company's website, CoreLogic.com, I have a much longer presentation which goes over lots of aspects of SADnets. So if you're curious about that, please contact me, or I can get you that presentation somehow. Now, this is just a graphical representation of what a SADnet truly is. You've got your virtual network here, or I'm sorry, this is the entire SADnet right here, completely segmented from your internet or internal network. There's no way for you to get from one to the other. Within your SADnet, you've got the sandbox and the virtual network, the network simulator. And these are usually 2 machines which are connected via a crossover cable or a hub or something like that, so they can communicate with each other. Now, simulating the network services on the network simulator portion of the SADnet can be done a couple of ways, but the most common way is to have scripts or programs which run as network services on that machine. Like I said, the network simulator, it's the part of the SADnet which is going to respond to the sandbox. Whenever the malware on the sandbox sends out a network request for whatever protocol it wants, DNS, IRC, SMB, FTP, whatever you have, it's going to respond and act like that service, so you can record what it does and how it interacts with services. It essentially is fooling malware to thinking it's online, and if implemented properly, it does a very good job of doing this. To give you an example, we've got our sandbox here and our network simulator, and they're connected via a crossover cable. We run some malware on our sandbox, and it sends out a DNS request for irc.bot.tld. The network simulator is going to intercept that, and it's going to respond with a DNS response saying that irc.bot.tld is at 192.168.10.87, a different IP address than what its actual IP address is. So, the malware gets this DNS response. It says, all right, I want to connect to an IRC server on port 6667 on IRC, the IP address that the network simulator sent back to us. Well, the network simulator is going to intercept that request via firewalls. Typically, it's done with IP tables, is how Truman does it with IP tables redirects. And it's going to act as that IRC server. It's typically what you have is an actual IRC server or Perl script or whatever other scripting language you want, which is going to send the IRC responses back to the malware, and then the malware is going to pretend to log it, or it's going to log into a channel, wait for commands or what have you, and you're going to be recording all of this information. So now you know what server it's trying to go to, what IRC channel it's trying to get into, any passwords it's trying to use for that IRC channel, and so on. So you can take that information and do research with it on the web, send it off to law enforcement, send it off to the IRC operators, or whatever you want to do with it. But you did all of this without it going to the web, without it going to the internet. Right. Yes?
Have you seen attempts with malware to use static IPs rather than main names?
Yes, the question was, have I seen attempts for malware to use static IPs as opposed to DNS? I have seen it. It's not done as common because with a static IP, if that gets shut down, the malware is SOL. However, with the way that the IP tables redirects are set up, it will still intercept that address and it will still respond to that address and pretend that it's that static IP address. Any other questions? All right. Now, if you look at what a SADnet is, where it's totally segmented from any other network, that poses a problem for us, because what we're trying to do here is give our SADnet a URL to go to get infected. If we don't allow outside access within our SANnet, that's a problem, because how are we going to go out and get that infection and just follow that infection to wherever it leads? I mean, yes, we could, step by step go and, use wget to go out to the first URL it tries to hit, and then, analyze that and then go to the second URL it tries to hit. But we run back into those problems of obfuscated JavaScript, the one-time hits, the browser dependencies, and so on, which are really causing our problems and are slowing down our analysis. So the solution is to use a hybrid approach. What we're going to do is we're going to take the analysis capabilities of our SANnet and then the control capabilities of a HoneyNet, put them together so we have our SANnet analyzing the malware, and then our HoneyNet control capabilities, a firewall, monitoring the network traffic going out to the web and then controlling it to be whatever we want. Essentially, we're just taking our SANnet and we're modifying the network traffic to allow it to go outside to the internet, to whatever sites it wants to go to. So as we go to our infection site, it's actually going to that site and it's actually grabbing that malware and continuing to do whatever it wants. Now, there are problems with this. I mean, we don't want our SANnet to get infected and then start attacking other machines. That's why we implement the data control capabilities of the HoneyNet into our hybrid SANnet. And I highly suggest going out to the HoneyNet Project's website and checking out their Gen 2 HoneyNet papers, because they do an excellent job with talking about the different ways to perform data control on network traffic going out to prevent it from attacking other systems. Well, to summarize, there are a couple ways you can do this. First, you can only allow certain ports outbound. So since we're analyzing malware, let's say I only allow port 80 and port 443 out. Well, the disadvantage to that is, well, what happens if my malware tries to connect to a web server or an IRC port on some non-standard port? It's not going to be able to go out because I'm blocking that. So that's not a great solution. The second one is to actually allow everything to go out but throttle it. Say we only want to let 20 packets per hour to go out, so that if it starts trying to scan other machines or perform exploits on other servers or send out spam, we're going to stop it after the first 20 or 30 packets. This does put your SANnet a little bit at risk of attacking other systems, but it really limits that risk as to what it can do. And usually, by throttling it, you're still going to be able to get the malware that you want and the infection that you want on your system. Finally, you can actually use a network intrusion prevention system like Snort, Snort's inline capabilities, to watch the network traffic and prevent additional attacks. So that if Snort sees an attack going out, it'll just drop the packet and not let it go out. There's a little bit of a problem with this, because if you do that, you could actually prevent your SANnet from getting infected, which is what you're trying to accomplish. And usually most SANnets, when they implement this to go to the hybrid approach to allow it to go out, they use a combination of the three. Now, in order to analyze web-based malware, we created an internal hybrid SANnet. We use it for malware analysis and software testing, and we found it particularly effective for analyzing web-based malware. The way we have our SANnet set up is it's based off of Truman, the open source SANnet, but we extended it using WebJob and custom coding. If you don't know what WebJob is, it's a open source project which allows you to schedule and execute requests through a web server, through CGI scripts on a web